Hey everybody, this is Charles from Thread and Signal, product designer here, and I primarily work with our 3D printed products, and today I'm going to teach you how to make threads. So, what you're going to need to start with is an open mind and and an ability to unlearn everything that you know, because there's a lot of information out there that is incorrect. The first is that that there's too small of threads or too big of threads, and that there's only a certain size that can work and things like that. And that might be true based on like the incorrect usage of certain people. But what I'm going to really teach you here how today is form shapes so that they fit within another and also fit relative to the 3D printed geometry and layer lines. So how this is going to work, we are going to first correct this design. So I like to give a basic overview of Fusion's thread tool here first. It's a very useful tool. It is basic though, and it is kind of limiting in the sense that it's basic, but it's also going to give you threads that will work in most situations and that are pre-made, and it's going to take a lot of time out of things unless you absolutely need it to be perfect, such as a case like this one that's a custom triple lead thread jar, which I'm also going to show you guys the design on in this case, or how to make that. Okay, so the first thing that we're going to do is we're going to select a thread design here. So the TR180, that's the diameter of the threads themselves. So in this case is a 180 millimeter diameter, and these are 28 millimeter lobes on these threads. So I like them big and chunky in this case. And what we're going to do, we're going to select OK on those threads there. And we're going to bring this object all the way back to the full timeline. We're actually going to, these threads are on the interior of the container, so you can see this is the interior of the container. We're actually going to delete those threads. So we are not going to use two sets of threads. We're going to make one set around the other. So we are going to delete this move tool here as well. And you might wonder to yourself, like, oh no, what have we done? This is all out of whack now. And no, it's not. I'm going to show you why. Okay, so we're going to increase this wall thickness to about 35 millimeters. That's pretty good for eyeballing it, wasn't it? It's because I didn't eyeball it. I measured it beforehand. But okay, so we're going to delete this off here. And we're going to see, I'm going to do this wrong intentionally up front to show you guys just the basic operation, but then I'm going to correct it to show you what's the way to do this. So when we do the combine cut operation, we select our target body, which is the thing that we're cutting into, right? Then we select our tool body, and that is the thing we are cutting with. So you'll see that the lid disappears because it's showing what it's cutting in this case, and you'll see that it's cutting that thread shaped space into the container. So in this case, it is going to, we're going to click OK, and we're going to click Keep Tool specifically, so it's going to keep this after it combines does the operation, and we see that we have perfectly cut threads. And in a perfect mathematical world, this is great, but the problem is that we have to account for the reality of 3D printing, which is that there's layer lines and thermal contraction inaccuracies and all kinds of dimensional instability that arises from this process, right? So what we're going to do here, actually going to increase this 1 little millimeter. Here we go. There we go. That's money. Okay. All right. So what we're going to do, the reason I did it wrong is that you can see that this is sharp like a blade right here. Like if you printed this would be like one layer line. You might cut yourself if this is like nylon or something, right? So we don't want that. That doesn't look good. And even if we turn off the sectional analysis here, we can just see it like looks weird. It looks bad. Now you might think to yourself, oh yeah, we're just going to fillet this bad boy out, right? And it'll look okay. You could do that, and that's perfectly okay. I mean, honestly, you know, you could do that, but there's a better way to do things, so we're not going to do that, okay? So what we're going to do is we're going to go to the lid, and we are going to go back to the combined cut operation here. I'm going to open the analysis again, and we're going to turn off the container, and here we go. Okay, we're going to make sure that we've got the whole thing. Yes, we do. Okay, we're going to fillet this part on the lid specifically. We're going to go as much as it can go. We'll say 7. And that makes sense because that's about, these were 28 millimeter lobes. That's a quarter. It's actually filleting by about 1/4 for the leading edge is pretty close to mathematically like what you want, according to the ChatGPT and some engineering book that I read. I don't know if that's true. Might be. But yeah, what I do know is this is going to be buttery smooth when this goes together. So we click container here. Let's put our fillet before that edge so that it actually shows us. Here we go. As we can see, it has greatly rounded out this edge here as well. And you might be concerned that, you know, is this going to have a little bit less holding force, things of that nature? Probably marginally so. If it's filleted by this much, if you're really that concerned with that, you can reduce the fillet amount, but I don't recommend reducing the fillet amount because when we undo this analysis and remove the lid, we can see that that edge is like perfect. Like it's pretty close to darn circular, which is hard to do with a single lead thread because it's an asymmetrical object, right? That brings us to our next theory. Well, and I guess before we get to our next theory of more threads, we're going to get to what we need to do in order to take this perfect shape and make it a really printable object, right? And that's with putting offsets on each side of the combined cut operation. So we're going to go one step beforehand, and we're going to turn off the combined cut operation by going one step beforehand, and we're going to bring up our analysis here again. We're going to see that we don't have the, you know, that we're not combined anymore. We're not cutting into this object. So we're going to make this container go away. We're going to bring everything into view here so we can select all of the faces. I'm going to select the whole object because it doesn't really matter in this case. If you have a precise use case, you could, you know, do the thing where you select each face. It can be tedious, and sometimes it can mess up what fillets actually work, or excuse me, what offset, well, actually what fillets too, be based on that, but it can determine if this offsetting operation actually works. So a lot of times the easiest way to do it is just to select the whole object because it has a lot easier time that way. Okay, so I'm going to offset this out. I typically do this by about 0.4 millimeters. You can do 0.2 is going to give you a nice snug fit, like, you know, the parts will go together on their first try without any post-processing with 0.2, but it's going to take a few twists of the lid to get it nice and smooth. 0.4 millimeters is just going to glide, like it's gonna feel really nice in the hand when you're. This is 0.4, and this is actually annealed polycarbonate as well too. So just to give you an example, you know, with what you're able to do. So let's see here. We're going to do the 0.4 millimeters. And then we're going to go to the end of our thing here. And then we're going to re-offset the face. We're going to select the whole thing again. And then we're going to go negative 0.4 millimeters. And what that's going to do, again, that's going to offset the face perfectly within the object itself. So what you're going to see is that, notice how that there's this nice space here. See that? Pretty nice, huh? Now, if you really had like an issue with something like that, well, I mean, honestly, you're going to have to fillet this edge anyway, so you could just fillet that out of the equation if you really had a problem with it. And then you could just extrude like this face back up. So here we go. We could extrude that up by 0.4 millimeters. There we go. And this is if you needed this thing to be like airtight, and then you were going to add like an O-ring thing there. I could keep going, and then, you know, you'd fillet this here. Whoops. No, you wouldn't. All right, just kidding. You didn't see that. But we're going to get rid of that. Okay. I could keep going, but basically you see the idea is to make a perfectly molded thread around the object, and then, you know, and then combine cut, and then offset that back just a little bit to the original size that it was, and that's what makes your nicely offset threads. And interesting. Okay. Well, cool. All right. Well, I'm fixating on that one a little too much, but I could show you some other thing, like just to give you an idea. This process, like this is a relatively complicated product, or complicated more jar design, but this is something that you know, uses the same premise as well, just to give you an idea there. So there's one other thing that I'll show you. And that is the triple lead thread. So that is going to be, as you can see, we use the same kind of design here with offsetting the threads, but these threads are a little bit different. And the reason why is that we have used a coil tool, and you can see that there is some pretty specific math that goes into doing this. It really is kind of just guess and try again kind of thing. But also I'm sure there's some math to it that someone smarter than me can figure out and hopefully leave as a comment there and share with everybody, or don't share it and get rich off of it, and, you know, like, because you know, why not? Just kidding. Don't do that. Please share it in the comments, right? Like and subscribe. I'm really building my audience here. Okay, so what we're gonna do though, and to show you with this operation, what a triple lead thread should ideally look like, and the reason you would do it, first off, is that whenever you have something like an O-ring seal, as I mentioned there before, you are going to have something that ultimately needs to have even compression from all sides, and a single lead thread is going to have one side where it presses down a lot more firmly than the other, creating an uneven seal. A double lead thread will have less of that issue, but it will rock on a certain 2 points. And then the first stable design is a 3 triple lead thread. And the other thing about that is that it actually increases travel distance per the amount of essentially thread bearing face. So this turns about 3 times faster than it would if it was just a single thread. And by turns 3 times faster, I mean you're getting 3 times the travel distance this way for each revolution. So even though it looks like there's a ton of threading on this lid, in reality, it's only about a little bit less than 1 full revolution for the turn of the lid in this case. So that kind of gives you an idea of what you can do with designs like that. But now I want to show you how you can use the combined cut operation in order to make something like a mold. So what I'll do, go back to Office Products, go to stress ball, and you'll see this does not look like a stress ball because it is a mold for a stress ball. So I will bring the stress ball back here, and I will make one of the halves go away. Here we go. So this is my funky chunky design for a stress ball. It's super fun. I'm not going to tell you how I made it because you could probably figure it out if you're halfway good at math. But it's really nothing special. But basically, what you do is you make multiple holes here, and you use those as ventilation holes, and you make your, well, I guess I should say the first thing that you do is you start with your stress ball, for example, or whatever it is that you're trying to mold. And then you use a combined cut operation. So we see combined cut right here, and that is what we use. I guess let me teach you guys here. Here we go. So here we go. Okay. So we have our stress ball, and then we would make a circular sketch. That we would then extrude. Oh, wait, no, just kidding. No, those aren't. Here we go. Okay. We would make this sketch that we would then extrude into a new component, and that new component would just be a cylinder, and then we would combine cut inside of that cylinder to get our object out. So they are now two different objects. Then we would use the creation of another sketch there in order to extrude. And what that would do is essentially, here we go. This sketch, oops, there we go. Making a sketch like this, so you can see it's basically a line, but it has two teeth, and extruding this sketch down as a cut. So that then turns this mold into two halves that interlock via the teeth. And I added two holes as well. Just for ventilation in this case. I could have just made like a hole in a rectangular pattern or something of that nature, but honestly just hit the hole tool twice. I mean, really takes 2 seconds. And then I filleted the edges up. I used, here's another tip for making molds that I've learned as well too. If you do a shell extrude around the holes, you lose a lot less stuff, a lot less silicone or whatever it is that you're pouring in these cases. Also, big disclaimer with these molds: if you're if you're using anything that's hot, like, you better know what you're doing. Like, do not try that at home. that's worth saying. Like, this is like for silicone and for people who know what they're doing, and for like grown-ups and stuff. So if you're like a kid, like don't do this as well. Or like, actually, you know what? I shouldn't say don't do this. I should say go get your grown up and have them help you with this, and have a fun project with them, but with your grown up. Okay. And anyway, after you shell extrude all that stuff there, you can then fill it over the edges, make everything look nice, and voila. So that is my mold design here. And whoops, that's what it'll look like on the inside. And yeah. Okay. Well, if you guys have any questions, you guys can send me a message on YouTube here, or leave me a comment. I can always answer some questions in a different video. Yeah, like and subscribe. Thanks for watching.